For lesson 14, we are going to be taking a look at some linear equations and their solutions. So for example 1, it says that Michelle looks at the equation negative 6x minus 30 equals 6x minus 30 and says that there is no solution. Is she correct? And explain. So if we were to solve this, we would have to move one of the x's over to the other side so that the variables were all on the same side. And we talked about last week how if we move the smaller coefficient of the variable, then we don't have to work with as many negatives. So in this case, I would want to work with that negative 6x. So the opposite would be to add 6x. Remember, I have to do that to both sides. So I have a negative 30 left over here, and then my equal sign. And 6x plus 6x would give me 12x minus 30. And then I'm going to add 30. And a negative 30 and a positive 30 makes 0, and that is perfectly fine to have 0 on one side. These 30s cancel, and I have 12x left. And then I'm going to have to divide by 12 on both sides. So x equals 0, because 0 divided by 12 is 0. Now, I knew at this step right here that there was a solution. And the reason for that is because that when I added 6x to both sides, it canceled here, but it did not cancel here. So if the variables would have canceled in both spots, then we would have possibly no solution. So because the variable didn't cancel out, then we definitely had a solution. If those would have canceled out, we would have had negative 30 equals negative 30 on both sides. And remember, if it's the same number, that's infinitely many solutions. So that means it has more than one solution. So it's this particular one still wouldn't have been a no solution. So the question asked, is she correct? No, there's one solution. And our explanation is here shown in the work. All right, the next one, I guess, determine whether each equation has one solution, no solutions, or infinitely many solutions. So we have to solve them. So for this one, we are going to distribute this 4 first. And then remember the equal sign is our barrier. So 5 times 4 is 20, and 5 times negative x would be negative 5x. And then on this side, I have negative 5x plus 20. Then I need to move a 5x, and they're both negative, so I'm going to add 5x to both sides. And this cancels out, and a negative and a positive 5 here cancel out as well. And I have a positive 20 on this side, and I have a positive 20 on this side. So this is infinitely many solutions. Okay, for the next one, when we distribute, we'll have negative 20, and then negative 5 times a negative x is going to be a positive 5x equals negative 5x plus 20. And I have a negative 5x on the right-hand side, so I'm going to add 5x. So I have negative 20, and 5 plus 5 is 10x. Our equal sign comes down, the 5x's cancel, and we have 20. Then I'm going to add 20 to both sides. So I have 10x equals 40, and then I have to divide by 10. So x equals 4. So we have one solution here. Just wanted to make sure that's what they were asking. And then this one, we're going to have to do 25, and then that would be negative 5x. This would be negative 5x plus 20, and I'm going to have to add 5x to both sides. So they'd cancel here, and I would have 25 equals 20. That is not a true statement, so this one is no solution. So what we kind of want to point out here is after we distributed, let's take a look at the equations that we had. Okay, infinitely many solutions. At that point, everything was the same. It wasn't in the same order, but we had a negative 5x and a negative 5x on both sides, and we had a positive 20 and a positive 20 on both sides. So they were the exact same equation, just written in a different order. Then when we had one solution, we had a positive 5x and a negative 5x. So we had different coefficients in front of the x's. And then when we had no solution, the x coefficients were the same, but the constants, the numbers, were different on both sides. So infinitely many, everything was the same. One solution, the coefficients in front of x were different. And then for no solution, the coefficients in front of x were the same, but the constants were different. So that's what we're kind of pointing out today. So this one says, write a number in the blank so that the equation will have that type of solution or solutions shown. So that first one is no solution. So if we go back up here, the no solution was our bottom one, and they had the same x values, but they had different constants. So this one has a plus 5 here. So I can put any number in this empty spot except for 5. So I'm going to put 10. Infinitely many solutions. If I go back up and we look, infinitely many solutions had the exact same coefficients with x and the exact same numbers on the constants on both sides. So this one has 1/3 x plus 5. The other side needs to be 1/3 x plus 5 as well to be the exact same for infinitely many. And then our other one here is one solution. So the one solutions was where our coefficients in front of x were different. So the left-hand side has a 1/3. I can put a 1/2, or I can put a 10. I can put any number there as long as it's not 1/3. And then here we have this equation we want to solve. So we have to distribute the 3 into the parenthesis, and we have to distribute the 2 on this side. And remember, this is our barrier, so we can't cross over that right now. So 3 times x is 3x, and 3 times negative 4 is negative 12. And then here is 2 times x, and then we have 2 times negative 6, so that would be a negative 12. And we are going to move the 2x because it's smaller, so I'm going to subtract 2x. So 3 minus 2 is 1x. Bring down the minus 12. 2x's cancel, and bring down this minus 12. So on the side with the variable, we got to get rid of that minus 12, so I'm going to add 12. And negative 12 plus 12 is 0, so x equals 0 in this case. Now, Brian says that there is no solution here. How do you think he got that answer? So there's not one correct answer here. He could have looked after the distribution was done right here. There was negative 12 and negative 12, so he could have seen that and decided that since those were the same but the x's were different, that there wouldn't be a solution. The other one that I thought of is because he got x is 0, he thought that 0 meant there's no solution. Can you think of any others?